Another type of motion graph is the velocity time graph. So time is on the x-axis and velocity is on the y-axis. Let's see what these different plots in a velocity time graph means. Let's look at plot A. In plot A, what happens to the velocity as time increases? So if you notice, at time t is equal to 0, the velocity is a positive value that is not 0, and then at a little later, the velocity decreases to some value. Then as time passes, it again decreases, but it does so at the same rate. So A represents velocity decreasing at the same rate, or we can say A represents negative acceleration or negative constant acceleration. What do you think B represents? The green line B. You're right if you said positive constant acceleration, because you can see that as time increases, B's velocity increases at the same rate. What does C represent? In the case of C, notice that the velocity does not change at all. It always remains at the same value as time increases. So C represents constant velocity or simply no acceleration. What does D stand for? Doesn't D look like B? So what is the difference between D and B? So D also increases the speed as time increases as well as B. But do you notice that the rate of increase of D is not as much as the rate of increase of B? So D represents the same, but the value of acceleration is less than that of B. So acceleration of D is less than acceleration of B. Couldn't we have found that if we understood that the slope of the line or the slope of the plot represents acceleration? Because the slope represents, if we take the slope of D, the slope represents change in velocity, which is the y variable, over change in time, which is the x variable. So therefore, the slope represents, in a velocity time graph, change in velocity over change in time, and we know that that represents acceleration. So you can look at whether it's sloping downward or upward and decide whether it is positive acceleration or negative acceleration. Okay. There is also another quantity that you can determine from velocity. So let's look at just a plot of velocity time graph which shows constant velocity like this. And let's put some numbers. Time is in seconds, velocity is in meters per second, and let's say this is 10 meters per second. So this represents an object that is moving at a steady speed of 10 meters per second in the same direction for a time interval that is a little more than 20 seconds. We want to know how far does the object go in the 20-second interval. That means I want to calculate the displacement of the object. We know that if the velocity stays constant, displacement is just velocity times time. So in this case, the velocity is 10 meters per second times 20 seconds, which is equal to 200 meters. But notice that I could have done this also as simply the area under the plot. So if I calculate this shape right here is a rectangle. So if I calculate the area of this rectangle, we know that area is length times width. So the length being, let us say, 20 seconds, the width being 10 meters per second. So it works out to be the same answer, 200 meters. So that means you can calculate displacement as simply the area of the plot in a velocity time graph. Would this work if it was not moving at a constant velocity? Let's see. Again, time in seconds, velocity in meters per second, and you have an object that is steadily accelerating. Let's put some numbers into this. So this is 0. Let's say this is 10 seconds. And let us say this is 10 meters per second. So if I wanted to calculate the displacement in the first 10 seconds, applying the same concept, I could calculate that as the area under the graph. So what does this shape look like? Yes, it's a triangle. So we know that area of a triangle is 1/2 base height. And if you see, the base here is just 10 seconds. The height here represents 10 meters per second. So we can write 1/2 10 seconds times 10 meters per second, which is 50 meters. So by using the formula that displacement is equal to the area in a velocity time graph, we have calculated the displacement to be equal to 50 meters. Let's apply the equation and see if we get the same answer. So we know that if velocity is changing, we need to compute the average velocity in order to calculate the displacement. So we can calculate displacement as simply the average, which is initial plus final divided by 2 times time. We can compute the average as the mathematical average because we know that the velocity is changing at a steady rate. So the initial velocity is 0 at the beginning of the time interval. The final velocity at the end of 10 seconds is 10 meters per second. So 0 plus 10 divided by 2 times the interval of time itself is 10 seconds. So you would still get the answer as 50 meters. So to summarize, in a velocity time graph, slope is acceleration, and the area is the displacement. Let us do a couple of questions on this velocity time graph to see if we understood the concepts. So let's first interpret the graph. So the first 10 seconds, the velocity is increasing at a steady rate, so constant positive acceleration. So positive A, velocity stays constant, so A is 0, and the velocity decreases with time, so A is negative, and then the velocity, the velocity decreases with time until this point, but then it's going in the negative direction and the speed is increasing. And then you can see that the speed is decreasing back to 0 and it's still going in the negative direction. So positive acceleration. So during this interval from 30 to 40 seconds, the acceleration is positive, but the velocity is negative, which is the reason why it is slowing down. Okay. So if I wanted to calculate the acceleration in the first 10 seconds, so we know that acceleration is the slope, which is change in velocity over time. So if we look at the slope of this line, so the velocity changes from 0 to 10. So it is going to be 10 meters per second change in velocity. And the time interval itself is 10 seconds. So this is 10 meters per second divided by 10 seconds, which is 1 meter per second squared. Let's say we want to calculate the displacement in the first 25 seconds. That means this is going to represent the area under the plot from 0 to 25 seconds. Look at this shape. This shape looks like a trapezoid. So if you know the formula for the area of a trapezoid, you can use the formula to calculate it. Otherwise, we can always split this into a triangle, a rectangle, and another triangle. So let's do that. So we are going to split this into different time intervals. So 0 to 10 seconds. Remember, displacement is equal to area. So this is a triangle. So the area for triangle is 1/2 base times height. The base here is 10 seconds. The height here is 10 meters per second. So it's going to be 1/2 times 10, which is 50 meters. So 0 to 10 seconds, it covered a distance of 50 meters. Now let's try 10 to 20 seconds. So this area is a rectangle. So the length of this rectangle is 10 seconds. The width of the rectangle is still 10. So therefore we can write delta x is equal to the area, which is length times width. So it is 10 times 10 is 100 meters. Then the last time interval between 20 and 25, again this looks like a triangle where the base is only 5 seconds and the height is 10. So delta x for 20 to 25 seconds. So delta x is equal to the area, which is 1/2 base times height, which is 1/2 5 times 10, which is 25 meters. And if I want the total displacement in that entire time interval, I just have to add up all the displacements because the displacements are all positive in the same direction. So the total displacement is equal to 50 meters plus 100 meters plus 25 meters, which will be 175 meters. So we can calculate displacement as simply the area. Alternatively, you could also have calculated the displacement by using the formula, and you have to do it separately for each interval of time because the motion during the first 10 seconds is different from the motion during the next 10 seconds. So you compute the displacement for each time interval and then add them up together. Here is something to think about. Between 25 and 40 seconds, notice that the area seems to lie below the time axis. What does that really mean? So something to think about, and we'll see again next time.